Look at your hand. Go on. Really look at it. It feels solid, doesn't it? You can wrap it on a table and hear a good, solid knock. And if I asked you what your hand is made of, you would tell me without hesitating. Atoms. Little bits of stuff. Tiny hard balls, packed together, stacked up into everything you can see and touch. The chair, the table, the mountains, the stars, the whole universe. Just stuff. Little things, built into bigger things. That is the most sensible idea anyone has ever had. It is also wrong. There are no little balls. There are no things. And before we are finished here, I am going to show you that the entire universe, you, me, this room, the farthest galaxy in the sky, is not built out of stuff at all. It is built out of vibrations, out of trembling, out of something singing. Let me first tell you why everybody believes in the little balls. Because it is a magnificent idea, maybe the finest idea anyone ever had about the world, and you should fall in love with it before I take it away from you. A long time ago in Greece, a man named Democritus asked a child's question. Take a piece of cheese and cut it in half. Cut that half in half. Keep going. Can you cut forever? Or do you reach a piece so small that it cannot be cut at all? He bet there was a smallest piece. The uncuttable thing. In his language, the atom. For a couple of thousand years, that was just a clever guess. Then the chemists got their hands on it, and something marvelous happened. They found that when substances combine, they always combine in tidy whole number helpings. 2 helpings of this gas grab 1 helping of that gas, and you get water. Every time. Never 2.5 helpings. Nature was counting. And you can only count when you have separate things to count. Whole things. Atoms. I will tell you how much I love this idea. Suppose all of science were wiped out tomorrow, every book burned, every memory erased, and you could pass just 1 sentence to the people who come after. What single sentence would carry the most punch? I would say this, that everything is made of atoms, little particles that jiggle about in endless motion, pulling toward each other when they are a small distance apart, and pushing away hard when you try to squeeze them together. In that 1 sentence there is an enormous amount about the world, if you only think hard enough about it. And look how much it explains. Why is a hot thing hot? Because its atoms are jiggling faster. Heat is just motion, the trembling of the little balls. Why does a flower have a smell that reaches all the way across the room? Because little pieces of it break off and go flying through the air and into your nose. Why does a gas push out against the walls of its container? Because countless tiny balls are drumming on the walls, a billion little knocks blurring into 1 steady push. Everywhere you look, the little balls do their work. The chemists even built a great catalog of them. Every kind of atom in its own square. The lightest one. The next. All the way up. A complete set of building blocks for the whole of creation. It was a triumph. It still is. So we are happy. We have our little balls. And they explain the heat and the smell and the pressure and the whole catalog of matter. Everybody goes home satisfied. And then somebody decides to do the obvious thing. If the atom is a little ball, let us look inside it. Let us throw something at it, very hard, and see what is in there. So they did. They took a sheet of gold, hammered incredibly thin, and they fired tiny fast bullets at it, and they watched where the bullets went. Now, if the atom is a solid little ball, you expect the bullets to plow through, slowed a bit, knocked about a little, the way a stone is slowed pushing through mud. And most of them did go straight through. But every so often, a bullet came screaming straight back, as if it had struck something incredibly small and incredibly hard and bounced clean off it. Think about what that means. It means the atom is almost entirely empty. There is a tiny dense lump in the middle, the nucleus, with nearly all the weight crammed into it, and then a vast amount of nothing, and then, way out at the edges, the electrons. How vast is the nothing? If you blew up an atom until its nucleus were the size of a pea sitting here in the middle of a great cathedral, the nearest electron would be a speck of dust drifting somewhere up near the ceiling. Everything in between is empty. Your solid hand, the one you just knocked on the table, is almost entirely empty space. The solid little building block turns out to be a few specks lost in a cathedral of nothing. That is the first crack. But forget the emptiness for a moment, because there is something far worse. Picture that electron, way out there, going around the nucleus like a tiny planet around a tiny sun. That is the picture in every school book. And that picture cannot possibly be true. Here is the trouble. When you swing an electric charge around in a circle, it has to throw off energy. It cannot help it. A charge whipping around a curve sheds little waves of light, the way a wet dog flings off water when it shakes. So our orbiting electron should be pouring out light, losing energy with every turn, and spiraling inward, faster and faster, until it crashes into the center. And if you sit down and do the arithmetic, the whole atom should collapse in less than the blink of an eye. Much less. About 100 millionth of a second. So answer me this. Why are you still here? Why is anything still here? If the schoolbook picture were right, every atom in your body would have collapsed before the universe had finished drawing its first breath. The little ball going around in its tidy circle is not a little bit wrong. It is a complete disaster. And things only get stranger when you go looking for the electron itself. You would like to ask the simplest possible question. Where is it? Where is the little ball right now? And nature refuses to give you a straight answer. You can catch the electron over here, you can catch it over there, but in between, when nobody is looking at it, it does not seem to have a where at all. It is not tucked in one spot like a marble in a drawer. It is smeared out somehow, spread, more like a fog than a pebble. Let me show you the experiment that drove a whole generation of physicists half out of their minds. You take a wall with two narrow slits cut in it, side by side, and a screen behind it to catch whatever comes through. Now you fire electrons at the wall, one at a time, slowly, so there is never more than a single electron in flight. Each one arrives on the screen as a single tiny dot. Good. That sounds like a little ball, landing in one place. But you keep going. Thousands of electrons, one after another, each leaving its own little dot. And slowly, the dots build up a pattern. Not one pile behind each slit, the way thrown pebbles would stack. Instead, you get stripes, bright bands and dark bands, marching across the screen. Bands where electrons land all the time, and bands right next to them, where electrons never land at all. Those stripes are the unmistakable fingerprint of waves. When two waves overlap, they add up where their crests meet, and they cancel out where a crest meets a trough. Stripes. So each single electron, sent through all alone, somehow went through both slits at once, overlapped with itself, and landed according to where its own waves piled up. A little ball cannot go through two doors at the same time, but the electron does it without blinking. So whatever an electron is, it is not a little ball. That is the third time we have said it now, in 3 different ways, and each time the news is worse for the little ball. And now I am going to hand you the puzzle that breaks the whole thing wide open. The one that, when you really sit with it, makes you feel you have been looking at the world upside down your entire life. Every electron is exactly the same as every other electron. I do not mean similar. I do not mean close. I mean identical, to a degree that has no match anywhere in ordinary experience. Every electron in your body, every electron in this room, every electron in a star, 10,000 light years away, has precisely the same mass, precisely the same electric charge, precisely the same spin, not nearly the same, exactly the same. As far as anyone has ever managed to measure, and people have tried extremely hard to find a difference and never once found one. Sit with how bizarre that is. Build 1,000,000 marbles in the finest factory on earth, and not one of them is truly identical to another. One has a faint scratch, one is a hair heavier. They are things, made one at a time, and separate things always differ somewhere if you look closely enough. But the electrons do not differ anywhere. You cannot scratch one. You cannot find a fat one or a thin one. They are perfectly, eerily the same, every last one of them, across the whole universe. So here is the question the little ball cannot answer. If electrons are little balls of stuff, who manufactured them all to be precisely alike, every single one, across billions of light years, with never one flaw? Ever? There is no answer. The little ball idea simply shrugs. It has nothing to say. So we are stuck, and we should admit it plainly. The little ball is hollow inside. It cannot orbit without crashing. It has no definite place when you are not looking. It goes through two doors at once, and on top of all that, it is mysteriously, perfectly identical to every other one of its kind. Anyone looking straight at that list has to concede the point. The thing we have been calling a thing is not a thing at all. We need a completely different idea about what the world is made of. So let us throw out the little ball and start again from the floor. I want to begin with a different kind of thing, or really a different kind of no thing. Picture a calm pond. The water just sits there, flat. Now I dip my finger in, and a ripple spreads out across the surface in a widening ring. Where did that ripple come from? I did not drop an object into the pond. I did not add a thing. The ripple is the water itself, moving. It is a pattern traveling across something that was already there, everywhere all along, and yet the ripple is perfectly real. It has a height, a speed, an energy. It can lift a floating leaf and set it bobbing. It is real, but it is not a separate thing sitting on top of the pond. It is the pond, vibrating. Keep that picture close, because it is the key to all of it. Here is another one you know in your bones. A musical note. When a singer holds a note, what is the note made of? It is not an object floating across the room. It is the air, trembling, pushing and pulling on your eardrum a few hundred times a second. Take the air away, and there is no note. The note is not stuff. It is a vibration in something that fills the room. And nobody is troubled by this. Nobody asks to be handed the note in a jar. We are perfectly comfortable with a real thing that is not a thing, so long as we call it music. So let me hand you the idea that all of physics is built on, the most important idea in the whole subject, and one that almost nobody outside the trade ever hears named. The idea of a field. A field is simply this: something that has a value at every point in space. That is the whole definition. Think of the temperature in this room. At every single point in the air there is some temperature. Warmer up by the lamp, cooler down at the floor. There is a number sitting at every point, the temperature right there, and that whole invisible arrangement of numbers filling the room is a field. You cannot hold it in your hand. It is not a thing, but it is utterly real, and you could go and measure it at any point you please. The first field that anyone truly came to understand is the one that carries light. There is something filling all of space, every corner of the universe, and we call it the electromagnetic field. When you shake an electric charge, you make a ripple in this field, and that ripple goes racing away at the speed of light. That racing ripple is light. The glow of this lamp, the warmth of the sun on your face, every color your eye has ever seen, all of it is vibrations traveling through the electromagnetic field. Light was never a hail of little things. It was always a trembling of a field that was already there. Some of us spent a good part of our working lives chasing down the details of how this field and the electrons speak to one another. And in the chase, we learned something that changes the whole game. If you look very closely at a ripple of light, you find it does not come in just any amount you like. It comes in lumps, smallest possible packets. You can have one packet of light or two, but never 1.5. We call one of these smallest possible lumps a photon. And a photon is not a tiny ball of light flying along. It is one quantum, one single indivisible shiver of the electromagnetic field. And here is where I ask you to take the leap with me, because the very same trick works for everything. If light is a ripple in the electromagnetic field, then what, I ask you, is an electron? The answer, the one it took the cleverest minds of an age to dare to say out loud, is that there is an electron field too. It fills all of space, exactly as the electromagnetic field does. It is everywhere. In this room, inside the sun, out in the cold dark between the galaxies. It is there, at every point. And an electron, the thing you spent your whole life picturing as a tiny hard ball, is nothing more than a ripple in that field, a vibration. The smallest vibration the electron field is permitted to have. 1 quantum of the electron field. And now listen closely, because the puzzle that defeated us is about to untie itself. Why is every electron precisely identical to every other electron? Because they were never separate little objects turned out by some cosmic machine shop. They are all ripples in one and the same field. Every electron in your fingertip and every electron in a distant star is a vibration in the single electron field that fills the entire universe. They are identical for exactly the same reason that every ripple on my pond is made of the very same water. There is only one pond. There is only one electron field. The ripples cannot help being alike, because they are all the same stuff doing the same dance. The eerie sameness that broke the little ball is not a mystery anymore. It is the most natural thing imaginable, and it does not stop with electrons. Every kind of particle that exists has its own field, filling all of space. There is a field whose ripples are the quarks, the pieces that huddle together in the heart of every atomic nucleus. There are fields for the rest of the particle family too, a whole household of them, all laid over one another, all filling the same universe at the very same time. Space is not an empty stage with a few things moving across it. Space is packed full of these fields, stacked one upon another, everywhere, all at once. And everything you have ever called a particle, a thing, a crumb of matter is a vibration, a note being sounded on one of these fields. Let me carry the music a little further, because it tells us something gorgeous about weight itself. When you pluck a guitar string, it sings at a particular pitch. Pull it tight and stiff, and it gives a high, bright note. Let it go slack and floppy, and it gives a low, lazy one. The pitch is built into the string. It is simply how that string wants to move. The fields are like that too. Some are stiff and some are slack. And the stiffness of a field is the very thing we feel out here in the world as the mass of its particle. A heavy particle is a ripple in a stiff field, a field that wants to vibrate hard and fast even when nothing at all is pushing on it. A massless particle, like the photon, the ripple of light, comes from a field with no stiffness whatsoever, a field that lies perfectly still until a wave is sent through it. So mass, the heaviness of matter, the stubbornness that makes a boulder hard to shove, turns out to be a kind of built-in trembling. A pitch the field hums it all on its own, even while it just sits there doing nothing. The whole weight of the world is a song the fields cannot stop singing. And the link runs all the way down. The faster a field vibrates, the more energy its ripple carries. A high, quick vibration is an energetic particle. A slow, gentle one is a feeble particle. The energy of the thing and the pitch of the thing are not two facts. They are one fact, wearing two coats. So when I tell you a particle is a vibration, understand that I am not reaching for a pretty word. I mean it with hard arithmetic standing behind it. There is one more surprise waiting, and it is a beauty. If the universe is truly made of fields, then ask yourself a sharp question. What is empty space? What is a perfect vacuum? A sealed box with every last particle pumped out of it. You would guess it is simply nothing at all. Silence, stillness, but the fields are still there. You cannot pull a field out of space, any more than you can pull the wetness out of the sea and leave the sea behind. The fields fill space by their very nature. And a field, it turns out, can never hold perfectly, completely still. There is always a faint, restless jitter running through it, a trembling that cannot be switched off, not by anything, not even at the coldest cold there is, not even with every particle removed. The quiet of empty space is not the quiet of nothing. It is the quiet of a calm sea, which is forever rolling, just a little, even on the stillest night. Empty space hums to itself. And that faint hum is not a fairy tale either. It leaves fingerprints we can measure in the laboratory, tiny shifts in the light that atoms give off, falling exactly where the field idea says they should. By now you may be thinking, this is a charming story, but is it true? Is it real? Or is it just a nice way of talking? So let me give you the hardest fact I know. When we treat the world this way, as fields and their vibrations, and we sit down to calculate something, say exactly how strongly an electron responds to a magnet, we can work the answer out to 10 decimal places. 10. And then somebody walks into a laboratory and measures the very same quantity. And the measurement agrees with the calculation to 10 decimal places. To give you a feeling for what that kind of agreement means, it is as if you measured the distance all the way from New York to Los Angeles and got it right to within the thickness of a single human hair. Nothing else in all of human knowledge lines up with reality that closely. And it only works, the numbers only come out right, when you treat the world as fields and vibrations. The little ball gives you garbage. The vibration gives you the most precise prediction the human mind has ever made. So when I tell you there are no things, only vibrations, I am not spinning a fable for you. I am telling you the thing that works. So let us go back to your hand, the one that felt so solid at the start. Look at it once more, with new eyes. It is not a clump of little balls. It is a small region of space where several fields are vibrating together in a particular, intricate, beautifully organized pattern. The electron field is humming there. The quark fields are humming there. The light field darts between them, carrying little shivers back and forth, holding the whole arrangement together. Your hand is not a thing, your hand is an event. Something happening. A cord being held in the air. And you, the whole of you, your thoughts, your memory of this very morning, the sound of your own name when somebody calls it, all of it is a pattern of vibration playing out across the fields of the universe. Not stuff. A song. And this is the thought I cannot put down. A song does not own its notes. The air carrying the music this instant is not the same air the next instant, and it makes no difference at all. Because the song was never the air. It was the pattern. One day the particular vibration, that is, you will come to its end, and the fields will fall quiet where you used to be, and the energy that was busy singing your song will wander off and sing other things. A stand of trees, a tide coming in, some child not yet born. But while it lasts, the pattern is real. The music is truly playing. You are not a small heap of things drifting briefly through a vast and empty universe. You are the universe itself, gathered up and vibrating for a little while as you. So tell me this. The next time you knock on a table and hear that good solid sound, will you be able to believe, even for 1 second, that anything in this world is really made of stuff?